let's see. Writing names of complexes. To represent coordination number, imagine coordination number means how many coordinate bonds are formed with the central transition metal. Okay, so that is coordination number. Okay, now to represent coordination number for monodentate ligand, use prefixes mono, di, tri, tetra, hexa, and so on. Okay, so what is that? To understand this, right, let's take one example. And I will call this number 1. Why I call this number 1? Because there are many rules. So with numbering, I can refer to it easily in future. So this is rule number 1. Example. This example again. Iron with 6H2O. We call it hexa aqua iron 2 ion. Okay, we don't want to focus on other part of the name first. We just focus on hexa first. So why hexa? Because there are 6 ligands here. 6. Okay, 6 H2O. H2O is the ligand. 6 of them. So that's why we call it hexa. The aqua here is the H2O The H2O Okay. So why H2O? Why H2O is named as aqua? So you can see here. H2O, aqua. Okay. In details, I will just pull it later why aqua. So we just move on first from here. The next rule is for bi and polydentate ligand, use prefixes mono, bis, tris, tetrakis, pentakis. Mono represent 1, bis represent 2, tris is 3, this is 4, and this is 5. Okay, so example. And let's say I name this rule number 2. Rule number 2. Rule number 2, let's say I put Fe. Okay, I need a bidentate now. Bidentate. Okay, so if you remember just now on page 2, there is a bidentate which is ethylene diamide. Ethylene diamide. The short form is EN. Ethylene diamide. Okay, EN. So for this bidentate, let's say I have, okay, let's say I have 3 of this bidentate. Okay, so, and then the charge is 2 plus. So the En here is ethylene diamide. So we are allowed to use En. Okay, instead of writing the long structures, so you can write En also. 3 of them. Okay, so how we name it? So I just write down first. This is actually ethylene diamide. Ethylene diamide. Ethylene diamide. Okay, so En. So there are 3 of them. We have to use tris instead of tri. Why you can't use the first version here anymore? Because the first version has been used in the ligand itself. You see, di is used already. This is the first set of numbering. Di has been taken. Di has been used. So now when you want to mention how many of the bidentate ligand, you have to use tris instead of tri, because the first level has been used here. So this is tri. Then how we, this is tris, tris. We have to use second level, trees. So how we name it? Trees, ethylene diamide, or trees N, iron, 2, ion. So the back part, don't care first. I just explain the front part. We call it trees because of 3 bidentate. Okay, now next point, name the ligand. Name the ligand. Okay, so on this part I skip first. Let us come back. Let us go straight to here first. Here. Okay, I call it rule number 3. Okay, rule number 3. Okay, rule number 3. Let's say I cover up everything here. Rule number 3. To name the central metal ions, the rule is if complex ion is positive or neutral. So you see the first 2 examples that I gave here, they are positive. As you can see, the charge is 2 plus for both example 1 and example 2. So they are positive. If they are positive, right, the central metal ions, they say use normal name. Normal name means what? English name, no? Fe is iron. So iron 2 ion. Okay, so this is iron 2 ion. This is the normal name. But let's see the next point. If complex ion is negative, that means you should expect some negative charge out here. Then you cannot use iron anymore. You have to change the name. Use name ending ATE. It's a special name here. So iron, you have to use ferrate. So I think this is the Latin way to call iron. Ferrum. Fe is ferrum. Now you have to change ferrum to ferrate. Lead, PB, right? Stand for plumbum. Plumbum change to plumbate. So copper, Cu, right? Cu is Cu. The Latin name I don't know what. Cuplum, cuplum, cuprum. Cuplum. Now change to cuplate. So if it's negative ions, you have to change the name to ATE. Okay, example. Number 3. So let's say I put FeCN6 4 minus. Okay, so for these structures, first you need to know Cn. Cn is actually a monodentate. If you can see back on the previous page, you can find that Cn is monodentate. It's cyanide. Okay, it's cyanide. So there are 6 of them. So we call this cyano, hexacyano. Okay, hexacyano. You can see this table here as well. Cyano, Cn, cyano. Okay, so hexa, cyano. Okay, after settle the ligand part, 6 of the ligand, which is hexacyano. Now you see the overall charge here is negative charge. So if it's negative charge, you look at rule number 3, iron have to change to ferrate. So we call it ferrate 2 ion. What it mean by ferrate 2? Why ferrate 2? Because, okay, imagine this is originally positive 2. And the cyano or the cyanide ion is having a charge of negative 1 each. And 6 of the cyanide end up with negative 6. Okay, negative 6. So positive 2 plus negative 6 end up with negative 4, the overall charge. So over here, let's come back to the bracket here. We put ferrate 2 because the iron here has oxidation states of positive 2, then ions. So that is how a negatively charged complex ion, the metal name is changed to ATE. Okay? ATE. So now, next one, let's say number 4 here. Okay, number 4. I come back to the top one here. Number 4 is about name of the ligands. If neutral and negative ligands present, first name negative ligand, then you name neutral. Okay, so I give example. Let's say example. Okay, I call it number 4. Let's say I have PtCl2 NH34 2 plus. Okay, let's say this is my complex ion. So you know the chloride here is Cl negative. As you can see, the table is negatively charged chloro. Then the NH3 here, which is called amine, is neutral. So based on rule number 4, they said name the negative ligand first. So I have to name chloro first. Chloro first. How many chloro are there? 2. 2 we use di because this chloro is monodentate. So dichloro. Okay, after that we name amine. So how many amine are there? Of course 4. So this is monodentate. For 4 monodentate we use tetra. So we use tetra. So tetra amine. Okay, now the platinum. So this is a positive complex ion. We can use platinum. Or else, if it is negative ion, we have to use platinate. So this is platinum then. Platinum. Okay. So after that, you have to figure out, you have to figure out what oxidation state is platinum. So I just do a quick calculation for you. This is -2 because chloride, each chloride take -1. So 2 chloride is -2. Amine is neutral. So you want to have an overall charge of +2. So platinum had to take +4 then. +4. So because of that, platinum 4 ion. So that is number 4. Okay, so this is rule number 4. Remember rule number 4, if you have negative ligand, name negative ligand first, followed by neutral ligand. So let's move on. Rule number 5. So you can see here, if ligand all neutral or negative, all neutral or all negative, which means, or contain more than one of each. So, contains a different type of neutral or different type of negatively ligand, name in alphabetical order. So this is where you have one type only, one type, all negative or all neutral. Then you see alphabetical order to name them. Let's say example. Okay, example number 5. If I have nickel C2O4 Cn 4 minus. So what is this C2O4? This is actually the oxalic ions. Oxalic ion. So oxalic ion is the bidentate ion. So bidentate. Okay, so it's it is negatively charged. The Cn is also negatively charged. So two of these are negatively charged. So when you want to name it, you have to follow alphabetical order. So this is oxalic ion, but when you name it, we call it oxalato. Oxalato. Why oxalato? Because, you know, for example, right, if the ligand is negative ion, you see the name end up with fluoride become fluoro, chloride become chloro, cyanide become cyano. Negative ion that change name end up with O. Hydroxide become hydroxol. This is oxalate ion become oxalato. 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 This one is cyano. Okay, so C come first, right? No? C come first. Alphabetical order, right? C come first. This is monodentate. Based on rule number 1, we use dicyno. Dicyno. Oxalato is bidentate. Based on rule number 2, bidentate, we use bis to represent 2. Bis. Bis. Oxalato. Okay. This is negative ion. Negative ion based on rule number 3. The nickel, you have to change it to nickelate. 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 Okay, now we want to know the nickel oxidation number. We have to do some mathematics here. So oxalato is negative 2. You can look at page 2 for the bidentate oxalato just now. So negative 2, 2 of them, negative 4. Cyano is negative 1, 2 of them end up with negative 2. Overall charge is negative 4. So nickel should take positive 2 then. Positive 2. So you have to do mathematics to figure out. And once you have decided on that, and then we put here 2 and then ion. 2 ion. So let's say just in case there is no charge outside, so you don't put ion. Okay, just for your information. You know, sometimes the transition metal and the ligand, their charge just cancel off, you know. So no overall charge, then don't put ion. Okay, now next point. Oxidation number of metal ion in Roman numeral. Roman numeral, that means this one, Roman 2, Roman 4, okay, and ion. Ion, like chromium 3 ion. Dichloro, tetra aqua. So dichloro, negative ion, right? So followed by neutral. Negative ion come first, followed by neutral, and then chromium 3 ions. Okay. So that is the naming part. Okay, now let's move on. So naming part we settled already with so many examples. Okay, so the next part we have 5.8, writing formulae of complexes. Metal ion is written first, followed by ligand. So you can see the example here. You see when we write the formula, FeH2O6. Fe is the metal ion, followed by the ligand. followed by the ligand, and then followed by the charge. Place charge on formula in square bracket. So if you see square bracket, you see example at the side here. So you put the charge after the square bracket. Okay? You see the square bracket here. And next point, total charge on complex is equal to sum of charge on metal ions and charge on ligand. So you have to count, something like number 3 here. This is positive 2, this is negative 6, then the overall charge is negative 4. But we write 4 minus, charge is in that format. Okay. If ligand all neutral, charge on complex equal to charge on metal ion. So this is the example. The H2O is neutral here. So the charge of ion, which is 2 plus, will be the charge of the overall complex. So it's 2 plus also. 5.9, shapes of complexes. So if they take 6 dative bond, like iron, which takes 6 dative bond, so this is octahedral shaped. If they take 4, we learn it in AS. If they take 4, logically tetrahedral. Okay, so but it is not just one situation, there is another shape which is on the next page. So over here, I give you some general idea in what situation they will form tetrahedral. Okay, so this is metal has D0 or D10 electron configuration. Particularly, but no need to know reason because it is university syllabus. So for just some brief explanation, they form tetrahedral because they have 4 dative bonds. And then I put some extra information here. This happens when it has D0 or D6. D0 or D6. So how? I need to care first. Okay, so we just move on to the next page.